Hi friends, how are you all? Hope you all are doing well. So today we are starting up with chapter number 1 of class 8, rational numbers. So in this session we will be doing the exercise 1.1 of rational numbers. But before starting up with that, first let's clear some concepts that are applied in the exercise and then we will move on. So first let me make a number line. Okay. Now we got 0, 1, 2, 3, 4, 5 and so on. And then we got minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 and so on. Okay. So now if I take numbers starting from 1 and moving on to the right hand side of the number line, those numbers are known as natural numbers. Or you can also say them as counting numbers. Why can we say them counting numbers? Because we can count on these numbers. How? Suppose if I say you that how many pairs of shoes do you have? Then one might say that I have only one pair of shoe. Another can say that I have 4 pairs of shoes. Okay? So some might say that I don't have any pair of shoe, but then that cannot be counted because you don't have any. So by this method we call them all as counting numbers. And what if I include 0 in this given set of numbers? Like if I include 0 with the positive numbers, then I will be getting whole numbers. So the set of numbers that starts from 0 and move on to the right hand side of the number line are known as whole numbers. And what if I include the negative numbers as well? But there's a condition that the numbers should not be in fraction or they should not be in decimals. So these all numbers, yeah, moving on to wherever they end, well the numbers don't ever end. So these all will be called as integers. Okay. But if I say you that I got, let me say I got here 1 by 2, okay, half. So will that be included in an integer? Well, that won't be included because integer just has 0, positive numbers and negative numbers. It does not have any fraction or any decimal. So in which criteria does this one lies? Well, let me tell you, that is rational numbers. Now you might be asking me that, friend, what are rational numbers? So let me just clear this one. Numbers that can be represented in form of P by Q. Let these both be any number such that P and Q are co-prime and Q not equal to 0. Because if Q becomes 0, then the number will be infinite. Okay, and why did I mention that P and Q should be co-prime? Well, co-prime itself defines that the numbers do not have any other common factor except 1. Okay, so if I take P as 4 and I take Q as 6, well, the condition won't be satisfied. It will be a rational number, but if we simplify it more, then it will be a rational number too. Okay, so if I take P as 4 and Q as 6, I will be getting a form of 4 by 6, but they are actually not co-prime. So what do we take? We just simplify it by dividing both by 2. We will be getting 2 by 3. And as you can see that if we get 2 by 3, 2 and 3 don't have any common factor except 1. So hope you have understood what are rational numbers. And now one thing that I would like to tell you. Well, you have done this one in 7th too, but first you must know that all natural numbers are included in whole numbers. So what we will be saying? We will be saying all natural numbers are whole numbers. But all whole numbers are not natural numbers, because whole number includes 0 but natural number doesn't. So we will be writing all natural numbers are whole numbers, but all whole numbers are not natural numbers. We can say that all whole numbers are integers, but all integers are not whole numbers, because integers include negative numbers but whole number doesn't. So what we will be writing? We will write all whole numbers are integers, but all integers are not whole numbers. Similarly, we can say with this one also that all natural numbers are integers, but all integers are not natural numbers. Okay, let me write that one. All natural numbers are integers, but all integers are not natural. Okay, and one more thing, as irrational numbers have also been introduced. So similarly, we can write that all integers are rational numbers, but all rational numbers are not integer. And similarly with these both, that all natural numbers or whole numbers are a rational number, but all rational numbers are not whole numbers or natural numbers. So we are done with the number line and explanation for the natural numbers, whole numbers, integers and rational numbers. Now let us move on to the properties of rational numbers. Okay, and under that too we will be studying closure property first. Then under that, first we will be dealing up with whole numbers. Okay, let me underline this one. And in that too, we will be first performing addition. Okay, so what does closure property basically means? It means that if you add any two whole numbers or integers or rational numbers, and so the result or the sum that has been obtained should be a whole number or an integer or a rational number respectively. And same is to be done with all four operators, that are addition, subtraction, multiplication and division, and we will be doing them all. Okay, so if we take two whole numbers, let me take 5 and 7, so result would come out to be 12, that is a whole number. And if I add 10 with 0, I will be getting 10. If I add a bigger number, let me take 60 with 19, I will be getting 79. So we can see that all three are whole numbers. So the statement that can be written for this one is whole numbers are closed under addition. Okay, and similarly let us do this one with subtraction. So very easy, just we need to interchange, or we can change the sign. So we will be getting 5 minus 7, that is minus 2, and we can see that minus 2 is not an whole number, it is an integer. So directly, if you get a single sentence that just denies that whole number is not closed under subtraction, then even if you get thousands of correct one, like I can give you many more like this. I can give you 6 minus 3, that is 3, and you will be calling it a whole number. Then even if you get one of the subtraction in which the result is coming negative or is not whole number, then the statement is directly that whole numbers are not closed under subtraction. Even if you give me thousands of the correct one, I would still give the statement because I have the one whose result is coming out to be a number that is not whole number. So I will be writing whole numbers are not closed under subtraction. Okay, similarly, let us do this one with multiplication. Okay. For multiplication, let me take any number. That must be a whole number. Okay, so I can take 8 multiplied to 9, that comes out to be 72, and it is a whole number. And then I can take 0 multiplied to 81, I will be getting 0, because anything multiplied to 0 becomes 0. And then at last, let me take one more example. That should be 12 into 12, that comes out to be 144, and that is a whole number too. So the statement that we will be writing is whole numbers are closed under multiplication. Similarly, let us do with the division. Okay, so for division, let me take any number. Let me take 7 divided by 1, I will be getting 7. And if I take 64 divided by 8, I will be getting 8. But what if I take 5 divided by 8, I will be getting 5 by 8. And as we have discussed earlier, that any of the fraction whose the denominator and denominator are co-prime, the number will be taken as rational number. So this one is not a whole number, it is a rational number. So I got one statement that just denies that whole numbers are not closed under division. So the final statement would also be the same, that whole numbers are not closed under division. Okay, let me just underline. So hope you have understood with whole numbers. Now let us perform the same with integers. So doing with integers, the first one, addition. Let me take an example. Let me mark examples out here too. These are examples too. Okay, so suppose let me take minus 5 plus minus 7. What will I get? I will get minus 12. Similarly, if I take minus 5 plus 8, I will be getting 3. And what if I take 5 plus minus 9, I will be getting minus 4. So here we can see that the numbers or the sum that we have obtained are all integers. So the statement that can be written will be integers are closed under addition. Okay, now similarly doing that one for subtraction. For subtraction, again let us take some examples. this would be 4. Then if I take this one would become 0, and if I take this one will become minus 14. So as you can see that all the three that have been obtained are integers. So we can write integers are closed under subtraction. Okay, now if I take the third one, that is multiplication. So again, let us take some examples for integers only. That will be 25, and then if I take, I will be getting minus 36. So here also we can see that the numbers that are obtained by multiplying the other two integers is also an integer. Okay, let me take one more example. That will be minus 42. So here we can see that all the numbers that are obtained are integers. So the statement that can be written for this one is integers are closed under multiplication. Okay, now we will be moving on to the fourth one, that is division. I will be taking the same example that I have taken in the whole numbers. I will just take 5 divided by 8. So that will give me 5 by 8. And again, that is not an integer, it's a rational number. So if I take any other example that just satisfies this, that won't be applied, because we have got an example that dissatisfies the integers that are closed under division. So the final statement that will come out to be integers are not closed under division. Okay, so we are done with whole numbers, and also we are done with integers. Now we will be doing for rational numbers. So now we will be taking rational numbers. Okay, again the first one will be addition. Let me take again examples to classify this one. For we need to take rational numbers, so 5 by 8 that have been used earlier, and then if I add this one with 6 by 8, I will be getting 11 by 8. That is a rational number. Similarly, doing up with taking the LCM, 8 into 2 is equal to 16, so I will be getting 4 plus 5, that comes to be out to be 9, and then we got 16 in the denominator. Okay, now as you can see that by the given examples, and if we take other examples, statement would be true that rational numbers are closed under addition. Are closed under addition. If I take another part for subtraction, I got they taking the LCM, that is 9, and if we multiply 3 into 3, that will be coming out to be 9. So in total we get 5 minus 6, that is minus 1 upon 9. Okay, so this one is a rational number. Similarly, doing that one with the above example, we will be taking 5 by 16. minus 2 by 8, again taking LCM, that is 16, and then multiplying it by 2, we get 5 minus 4, that is 1 by 16. So again, by the given examples or other examples that we will be taking or we can take, the statement is satisfied that rational numbers are closed under subtraction. Okay, and now if we move on to the third one, that comes out to be multiplication. So here we will be seeing 9 gets cancelled, and then we have 5 by 1, that is a rational number. And if I take another, let me take this one as 6 by 18 into 9 by 3. What will I get? Okay, divided by 3 divided by 9, and then we will be getting 1. That is also a rational number. And let me give you, okay, so now if we see, and let me give you one more, okay, so I can give you, this one is separate, we will get 5 by 18, that is a rational number too. So the following examples, again let me write examples, the following examples are satisfy that rational numbers are closed under multiplication. Okay, and now let us move on to the last one, that is division. So for division, we see that, let me take 9 by 5 divided by 9 by 5, that comes out to be 1. 3 by 2 divided by 0. Now here we see that 3 by 2 is divided by 0. So the result that will be coming out by solving this one will not be a rational number. So the statement that will be written will be rational numbers are not closed under division. Okay, so this was our closure property. Now let's move on to the commutative property. Okay, so now what is basically happening in commutative property? Okay, so we can say that when we add two numbers, then if we reverse the number, then the addition or the result that comes out is to be same. So let me explain you by giving an example, that if I take x plus y, then whatever the result would be coming out will be equal to y plus x. Okay, so now we will starting with the whole numbers first. Okay, and that too we will be taking addition. So now we will doing quickly because we have the base of class 7th. For addition, suppose if I take 9 plus 2, that will be 11. And what if I take 2 plus 9? That's 11 too. So that is equation number 1 and that is equation number 2. So we can write from 1 and 2, 9 plus 2 is equal to 2 plus 9. Or you can just verify it. How? 9 plus 2 is equal to 11 and 2 plus 9 is equal to 11 too. Okay, and now we will doing for subtraction. How do we do for this one? Again, let us take the same numbers. 9 minus 2 is equal to what? It is 7. And if I take 2 minus 9, that is equal to minus 7. Again, let us name the equations. And then what do we have? From 1 and 2, we can see that 9 minus 2 is equal to 7, but 2 minus 9 is not equal to 7, but it is minus 7. So we can write that 9 minus 2 is not equal to 2 minus 9. Okay, so we will be writing that, what can we write? We can write subtraction is commutative, not commutative under whole numbers. Similarly, we can write for addition, as the equation was verified. So we will be writing addition is commutative under whole numbers. And now if we proceed to multiplication, okay, so in multiplication, let us take an example, like again 2 into 9, that is equal to 18, equation 1, and if I take 9 into 2, that is equal to 18 too. So again we can write from 1 and 2, 2 into 9 is equal to 9 into 2. So we can write that multiplication is commutative under multiplication under whole numbers. Okay, and now if we see for division, what do we see? Let me take again 9 divided by 2 is equal to 4.5. Also 2 divided by 9 is equal to, let me calculate this one, they will be coming out around 0.2 bar. So again from 1 and 2 we can see that 9 divided by 2 is not equal to 2 divided by 9, because 9 divided by 2 is equal to 4.5, but 2 divided by 9 is equal to 0.2 bar. So it is not commutative. So we will be writing division is not commutative under whole numbers. So here we are done with the whole numbers for commutativity, and now we will be doing for integers. Okay. So what do we get to see out here? First, again we will be doing addition. Okay, now let me take any integer. Let it be minus 4 plus minus 5. Both are integers, and then the final answer that I have is minus 9. Okay, and this, let this one be equation 1, and then if I take minus 5 plus minus 4, then this one will be minus 9 too. Okay, equation number 2, and then we can write from 1 and 2 minus 4 plus minus 5 is equal to minus 5 plus minus 4, and that is what is needed to be proven. X plus y is equal to y plus x. So what will be the statements? That addition is commutative under integers. Okay, and now if we do for subtraction, again we will be taking the same numbers, minus 4 and minus 5 is equal to, this one becomes 1, let this be equation number 1, and then if we got, okay, let me reverse this, minus 5 minus 4, that is minus 1, equation number 2. So from 1 and 2 we see that minus 4 minus 5 is equal to 1, but minus 5 minus 4 is equal to minus 1. So minus 4 minus 5 is not equal to minus 5 minus 4. So this would be minus 4 minus 5 is not equal to minus 5 minus 4. And what will be the statement? This would be subtraction is not commutative under integers. And now let us move on for the multiplication. Now we got multiplication. What do we do? Very easy. Again, taking the same examples, minus 4 into minus 5, which is equals to, minus into minus we get plus, that is plus 20. Similarly, if let this one be equation number 1, and if we take minus 5 into minus 4, that would be minus 20, that would be 22. Okay, that would be equation number 2. So from 1 and 2, what do we see? That minus 4 into minus 5 is equal to minus 5 into minus 4. So the statement that can be written is multiplication is commutative under integers. Okay, and now if we move on for the fourth, that is division. How do we deal with this one? Again, taking the same examples, minus 4 divided by minus 5 is equal to, okay, so this one would be 0.8. Okay, 0.8. Let me write 0.2 bar. Okay, and if I do minus 5 divided by minus 4, equation number 1, so this one would come out to be, okay, so this one would be 1.25. As you can again see that minus 4 divided by minus 5 is equals to 0.8, but minus 5 divided by minus 4 is equals to 1.25. Therefore, minus 4 divided by minus 5 is not equal to minus 5 divided by minus 4. The statement that again will be written is division is not commutative under integers. Hope you all are cleared till now. Now let us proceed to rational numbers. Okay, so for rational numbers, first again addition. In addition, we take rational numbers, let it be 5 by 3 and 9 by 3. So what will we get? We will be getting 14 by 3. Let this one be equation 1, and then if I take 9 by 3 plus 5 by 3, that will be 14 by 3 again. So we write from 1 and 2, 5 by 3 plus 9 by 3 is equal to 9 by 3 plus 5 by 3. So the statement that can be written out here will be addition is commutative under rational numbers. Okay, and now let us do with subtraction. So again, let us take the same examples. 5 by 3 minus 9 by 3 is equal to minus 4 by 3, equation 1, and then 9 by 3 minus 5 by 3 is equal to 4 by 3, equation 2. Again, here from 1 and 2 we can see that 5 by 3 minus 9 by 3 is equal to 4 minus 4 by 3, and 9 by 3 minus 5 by 3 is equal to 4 by 3. But minus 4 by 3 is not equal to 4 by 3, therefore 5 by 3 minus 9 by 3 is not equal to 9 by 3 minus 5 by 3. This will be written like this: 5 by 3 minus 9 by 3 is not equal to 9 by 3 minus 5 by 3. Statement: subtraction is commutative under is not, keep a note, subtraction is not commutative under rational numbers. Now let us do for multiplication. What do we do for multiplication? Same examples will be taken. 5 by 3 into 9 by 3 is equal to, this one becomes 5. Okay, and if I take 9 by 3 into 5 by 3, that would again become 5. Equation number 1, equation number 2. So again from 1 and 2 we can say that 5 by 3 into 9 by 3 is equal to 5, and 9 by 3 into 5 by 3 is also 5. So 5 by 3 into 9 by 3 is equal to 9 by 3 into 5 by 3. So statement: multiplication is commutative under rational numbers. The last one that is to be taken, division. Division. What do we see out here? Again, let's perform. 5 by 3 divided by 9 by 3. It will be reciprocated, and then we will be getting 5 by 9. Similarly, this one will be equation number 1, and if we take 9 by 3 divided by 5 by 3, this one will become 9 by 5, equation number 2. So from here we can see that 5 by 9 is not equal to 9 by 5. So 5 by 3 divided by 9 by 3 is not equal to 9 by 3 divided by 5 by 3. So statement: division is not commutative under rational numbers. So with this we are done for commutativity. So now we will be starting up with associativity. And under that we will be first handling up with whole numbers, and under that too we will be first doing addition. So as we have now we have the base of closure and commutative, then this would be easy. I will be taking one example for each, for associativity, whole numbers and addition. Okay, so for associativity it is needed to be verified that a plus b plus c, hope you are able to understand, is equal to a plus b plus c, like this. Okay, so we just need to prove, or we just need to verify this one, and we're done. For the addition, let me take 5 plus 7 plus 8. Okay, so what will be the answer for this one? 7 plus 8, we get 15, and plus 5, we get 21. Similarly, if I do 5 plus 7 plus 8, 5 plus 7, we get 12, and 12 plus 8, we get 20. So from equation 1 and 2, what do we get? We see that 5 plus 7 plus 8 is equal to 20, and in equation 2 also it is 20. So we will write 5, 7 plus 8 is equal to 5 plus 7 plus 8. So addition is associative under whole numbers. And now we will be doing with subtraction. What do we do for subtraction? We will be just reversing these, so changing of the signs. 7 minus 8 is minus 1, and we have a minus sign out, so it will be plus 1, and we get 6. And if I do like this, minus 2 and minus 8, we get minus 10. As you can see that 6 is not equal to minus 10, so it is not satisfying the statement of associative, so we will be writing subtraction is not associative under whole number. Similarly, let me just write it out from 1 and 2. Okay, now we will be doing for multiplication. So for multiplication, we will be taking the same 5 into 7 into 8. Okay, so we see 7 into 8 is 56, and 56 into 5 is 280. Similarly, doing with 5 into 7 into 8, 35 into 8, that is 282. As you can see, the result is same on both the sides of RHS. Therefore, 5 into 7 into 8 is equal to 5 into 7 into 8 from 1 and 2. Again, the statement multiplication is associative under whole numbers. Now we will be doing the fourth, that is division. So again, let us take some separate numbers so that it will be easy to calculate. Let me take okay, so the answer to this one will be 4 divided 2 divided by 2, we get 1. 4 divided by 1, we get 4. And similarly, doing with the 1, 4 divided by 2 divided by 2. So 4 divided by 2 is equals to 2, and 2 divided by 2 is equals to 1. So this forms equation number 2, and we can see from 1 and 2 that 4 divided by 2 is not equal to 4 divided by 2 in brackets and divided by 2. Okay, so again the statement division is not associative under whole numbers. Okay, so now we will be doing this one for integers. So again, first one, addition. So now we can take So the answer to this one will be minus 9 plus 7 we get minus 2, and minus 2 we get minus 4. Equation number 1. Similarly doing with this. Okay, now brackets will be applied out here. This will be minus 2 minus 9 we have minus 11, and plus 7 we have minus 4, and we can see from 1 and 2, minus 2 is equal to, it's 9 plus 7. Okay, and the statement for this one, we will be writing addition is associative under integers. Under integers. Same doing up with the second part, subtraction. What do we get out here? Let me take the same examples. Okay, so let us do these first. Minus 9 minus 7 we get minus 16, and then it becomes plus 16, and minus 2 we get 14. Similarly doing up with okay, now brackets won't be applied. So this one become plus 9 and minus 2 become minus 7. Plus 9 minus 2 we get 7, and 7 minus 7 we get 0. So as you can see from 1 and 2 that it's quite tricky to handle up the brackets and associative. Is not equal to. Okay, so the statement for this one we will be writing subtraction is not associative under integers. Now we will be doing the third, that is multiplication. Now for multiplication we will be taking the same examples again. So first we will be solving this one. Minus 9 into 7 we get minus 63, and minus 63 into minus 2. Let us do that in rough. Okay, so this will be minus 63 into minus 2, that will become plus 6, and we got 126. Okay, so the answer to this one will be 126. Similarly doing this minus 2 into minus 9, implementing the brackets, putting it in brackets, and then to 7. Minus 2 into minus 9 we get plus 18, and plus 18 into 7 is 126. Again 1, 2. So again we can see from 1 and 2 that minus 2 into minus 9 into 7 is equal to statement multiplication is associative under integers. Now we will be doing the fourth, that is division. Okay, so let us again take different one. Let me take this only. 4 divided by 2 divided by minus 2. First we will be solving this one. We get 2 divided by minus 2 is minus 1, and 4 divided by minus 1 is minus 4. Similarly, doing out here, we get 2 out here, and 2 divided by minus 2 we get minus 1. So from 1 and 2 we again see that the result on both the sides are different, so these are also not equal, and if they are not equal then they are not associative. So division is not associative under integers. Okay. So now we are done with integers. Now let us move on to rational numbers. For the first, we will be having rational numbers. Again, first one will be addition. And now for addition, we will be taking rational numbers, right? So let us take 5 by 3 plus 9 by 3 plus 8 by 3. So what will be the result for this one? 9 plus 8 we get 17 by 3, and 17 by 3 plus 5 we get 22 by 3. And if we do like this, we will get 9 plus 5 is 14, 14 plus 8 is 22 by 3. So here also we can see from 1 and 2 that 5 by 3 plus 9 by 3 plus 8 by 3 is equal to 5 by 3 plus 9 by 3 plus 8 by 3. Addition is associative under rational numbers. Rational numbers, using the short form. Then again we will be going on to subtraction. Same. One by 3 and 5 by 3 minus 1 by 3 we get 4 by 3, 1. Similarly, doing like this, so it will become minus 4 by 3, and then minus 8 by 3 becomes minus 12 by 3. So again from 1 and 2, from 1 and 2 we can see that is not equal to 5 by 3 minus 9 by 3 in brackets, and then minus 8 by 3. Okay, then we will write the statement that subtraction is not associative under rational numbers. Okay, now we will be moving on to multiplication. Okay, so in multiplication we will be taking this different sets of number. Okay, so let me form multiplied, multiplied. Okay, so this might work. This will get cancelled, and again they will get 3, 3. So we are left with 1 by 5, and then 5 will get cancelled out by the outer one. So in total we are left with 1 by 3, 1. And if I do that one in other way like this, 5, and then this is cancelled out, then we got 3, and at last we have 1 by 3. That is equation number 2. So again, by seeing from equation 1 and 2, we see that the result is same, so it is associative. Let us write this statement that multiplication is associative under rational numbers. At last we got division. So in division, we will be taking numbers like these: 3 by 5. Okay, sorry, this is division. So divided by 3 by 5, and then we got divided by 9 by 25. First you will solving this one. This one becomes 1, and 1 divided by 9 by 25. So 1 divided by 9 by 25. This one will become 25 by 9. Okay, and then doing the same, I have left with less space, so we will be writing 3 by 5 divided by 3 by 5 divided by 9 by 25. Okay, so when we reciprocate this, we get 5 by 3, yes, and then again that will be reciprocated, so this one will become 5 by 3, and when that will be reciprocated, it will become 1. Okay, so we can see that both the equations have different answers, so they are not associative. Let me write the statement that division is not associative under rational numbers. So here was the associativity. Now we will be moving on to the role of 0. Okay, so under role of 0, first let me give you some examples. Like if I add a whole number, if I have a whole number 25, and if I add it to 0, I will be getting the number itself, that is 25. So let me give you one more example, like 36, and adding up with 0, it will be giving me 36. Or I can also write it as 0 plus 36 or 0 plus 25. Okay, as you know, it is a commutative property. And then we have claimed that if we add 0 to any of the whole number, we will be getting the number itself. Now let us do this one with integers, like minus 12 plus 0 is equal to minus 12. That is equal to, minus 12, and that is equal to 0 plus minus 12. Okay. Okay, and if I take any other example, like 0 plus minus 9, that would be minus 9. That is minus 9 plus 0. So we are also cleared up with integers, that if we add any integer to 0, the answer will be the integer itself. And if I do with any of the rational number, like 2 by 7 plus 0, I will be getting 2 by 7. That can be represented as 0 plus 2 by 7. Similarly, we can do with many other numbers that are integers, whole numbers, and rational numbers. So we say that 0 is the additive identity for whole numbers and integers and rational number. Okay, so this was the role of 0. Now we will be moving on to role of 1. Very easy. We have just done addition with the number. Here we will be doing the multiplication. So if I take any of the whole number, let me signify. Whole number, integer, rational number. And in this, if I take any of the whole number like 5 and multiply it with 1, I will be getting the number 5 itself. And then if I take 9 and multiply it with 1, I will be getting the number itself. So we are done with whole numbers. And if we move on to integers, minus 5 into 1 is equal to minus 5. And if I take minus 36 into 1 is equal to minus 36. So we are also cleared up that in integers also it is applicable, and if I take rational number like minus 2 by 7 into 1 is equal to minus 2 by 7, or if I say 2 by 7 into 1 is equal to 2 by 7. So here we are done with rational numbers too. So what will be the statement formed? The statement will be that 1 is the multiplicative identity for whole numbers, integers as well as rational numbers. So I will be writing here 1 is the multiplicative identity for whole numbers, integers as well as rational numbers. So hope you all are cleared with the role of 0 and role of 1. Now we will be moving on to the negative of a number. Suppose if I take 2, okay, and if I add something in it, that the result is 0. So what you will do? First we will be taking the number as x, and then if 2 plus x is equal to 0, then x is equal to minus 2. Therefore if I put minus 2 on place of x, I will be getting a 0. So for negative of a number, if we have 2, then the negative of the number, if applied at the place of x, then the result will be 0. So if I say for 7, negative of the 7, we get for 7, negative of the 7 is minus 7, and to verify it, 7 minus 7 is equal to 0. Similarly you can do that with integers, like if I have minus 10 and the negative of this one will be minus of minus 10, that is plus 10. Okay, so again verifying this, minus 10 plus 10, that is 0. And if I take for rational numbers, minus 2 by 7, what is the negative of the number? That is plus 2 by 7. And what do we get in total? Minus 2 plus 2, that is 0 by 7. That is 0. So we can see that negative of a number in any of the criteria, like for the whole numbers or the integer or the rational numbers, can be found. Now similarly moving up to the reciprocal. Okay, so for reciprocal it says that if I take a number 2 by 3 and then multiply it with any number, let it be y, then the result should be 1. So now let us do this one. This would be 2y by 3 is equal to 1. Taking 3 to the other side, 2y is equal to 3, and taking 2 to the other side, y is equal to 3 by 2. So y is basically the number that when multiplied to other, then it will be giving 1. Okay, so here we find that y is equal to 3 by 2. Okay, let's check this one. 2 by 3 into 3 by 2. We see that every number gets cancelled, and at last we are left with 1, and that is what is required. So we say that 3 by 2 is the reciprocal of 2 by 3. Similarly, we can, this was for rational, we can do for many others, like for integers. I can give you an example. For integers, let me write it out here. 2 into dash is equal to 1. Okay, so if I take y out here, then 2y equal to 1, y equal to 1 by 2. Okay, so and then we multiply, then 2 gets cancelled, and last we are left with 1. So we can say that if we are now given a number, the reciprocal of this one is actually the inversion. As you can notice out here that 2 by 3 when inverted, like the denominator is numerator and numerator is denominator, that is 3 by 2, and that is what is obtained. Similarly here it is 2 by 1, and when we invert these we get 1 by 2. So hope you have understood what is reciprocal. And let's do for integers. Minus 5 into y equal to 1. Then reciprocal of minus 5 by 1, inversion, we get 1 by minus 5. So y is equals to minus 1 by 5. That is the reciprocal of the number. So we are done with all three of them. Now we will be doing distributivity of multiplication, distributivity of multiplication over addition for rational numbers. Okay, so suppose if I take three numbers, rational numbers, so if I have 2 by 3 minus 2 by 3, then I have 3 by 8, and then I have, okay, now let me take the 16, then I have 16 by 12. Okay, so first let's do the multiplication with associative property, and then we will be doing multiplication individually and then adding them up. Okay, so using multiplication property, you can take any two of them. I will be taking this. Okay, so here we have 24. Okay, so this one will become minus 2 by 3 into this one will be 2 times, and this one will be 3 times, so this will be 9 plus 32 by 24. Okay, and then this will become 41. Okay, so we will be left with minus 2 by 3 into 41 upon 24. This one will become 12 minus 41 upon 36. So this is what we are left with, and now we will be multiplying these both and then these both, and at last the result that came, we will be adding them up. So we get minus 2 by 3 into 3 by 8, that becomes minus 1 by 4. Similarly, doing minus 2 by 3 into 16 by 12, we get, this one becomes 6, and then 8, this one becomes 3. So at last we are left with minus 8. Then we will be having minus 8 by 9. So we just add them both. That is 1 by 4 plus minus 8 by 9. LCM for these. Okay, so we have 36. This one is 9 and this one is 4. So we have that is minus 9 by 36, and then multiplying 4 to this, minus 32. Then this one becomes minus 32 divided by, oh, this is whole 36 only, so let me write it in between, 36. Okay, so minus 9 minus 32, we get minus 41 by 36. And as you can see that it is similar to what we got earlier. So the relation that we get is minus 2 by 3 into 3 by 8 plus 16 by 12 is equal to minus 2 by 3 into 3 by 8 plus minus 2 by 3 into 16 by 12. So this is the relation that we have got and is also known as distributive property. And now we are starting up with exercise 1.1. Okay, and here we do question number 1. It says, using appropriate properties, find, we are given the first part, say minus 2 by 3, and then we have, okay, so we have a multiplication sign out there. We have multiplied 3 by 5, and then we have 5 by 2, then we have 3 by 5, and at last we have 1 by 6. So here we can see that we have 3 by 5 common in both the multiplications, as you can see out here. You may say that it is minus 3 by 5, but that doesn't matter because you have a minus 2 out here. And in multiplication, if I take it out here or if I take it out here, it doesn't matter. So now first let us arrange this. So that will be given us by minus 2 by 3 into 3 by 5, and then if I subtract it, because if I am taking this whole out there, it will be subtracted. That is 3 by 5, and then I have my 1 by 6. And at last I have 5 by 2. So this was done by the help of commutative property. As you can arrange it in any way, the result would be same. Okay, so and if I take that in brackets, that will be easy to understand. Now if we see that if I just remove this negative sign out here and I just put it out on 3 by 5, we have minus 3 by 5 as common. So I would take minus 3 by 5 out of the brackets, and then I will be left with 2 by 3 and adding it up with 1 by 6. And at last again we are left with 5 by 2. So what I have done out here is actually a reverse of distributive property. As we know, distributive property says that if we are having numbers like this, so for distributive property it will come out to be AB plus AC. So what we have done out here, we have A as minus 3 by 5. Okay, so if I take the A common, then I will just reverse this one. That will be in the form A and B plus C, that is not common in the bracket. So as you see that 2 by 3 and 1 by 6 have is not common, so it will be taken in the bracket. And whereas you can see minus 3 by 5 is common in both the cases, so we take it outside the bracket. Now let's solve this. We have LCM as 6, so let me write it. Minus 3 by 5. You must not forget to mention distributive property. Okay, so now if I take LCM as 6, so then I will be multiplying it by 2 in both numerator and denominator. That will give me as 4 by 6. And if I add it by 1 by 6, I will be having 5 by 6. And then at last I have 5 by 2. So again doing minus 3 by 5, 4 plus 1, we get 5 by 6. Okay, and if I add it with 5, and now I will be adding it with a 5 by 2. Now we see that minus 3 by 5 is multiplied to 5 by 6. So 5 will get cancelled out and it will become minus 1, and this one would become 2. So we are left with minus 1 by 2 plus 5 by 2, and we all know that minus 1 plus 5 is 4. So 4 by 2, that is 2. So this was the answer to part 1. Now we will be proceeding into part 2. Again we have 2 by 5, then into minus 3 by 7, then we have minus 1 by 6, and then we are multiplying it by 3 by 2, adding up with 1 by 14, and again multiplying it by 2 by 5. So we need to find the similars amongst the multiplications. As you can see in these both multiplication, we find out that 2 by 5 is common. Okay, so first again we will be rearranging this. That would give us 2 by 5 into minus 3 by 7. Then we have a positive sign or plus a sign, so we will be writing it out like this, plus 1 by 14 into 2 by 5, and then again at the last we are left with minus 1 by 6 into 3 by 2. Okay, let me take this one in brackets again. This was commutative property. Commutative property. So now let's solve this one. As you can see, 2 by 5 is common, and the same property, that is distributive, will be applied out here. So we will be having 2 by 5 as common, that would be outside the brackets, and then we are left with minus 3 by 7 and plus 1 by 14. And at last we are also left with minus 1 by 6 into 3 by 2. Okay, moving on further, we have we just need to simplify this one, and we can see the LCM is 14. So this one would be multiplied by 2, whereas this one would be multiplied by 2 also. So this would come out to be minus 6 by 14. So let me write this, 2 by 5, then we have minus 6 by 14, and then we have plus 1 by 14. Okay, and at last you are having 1 by 6 into 3 by 2. Now similarly, if I move on, minus 6 plus 1, we have minus 5 by 14. So we will be having 2 by 5, and then in the brackets I will be having minus 6 plus 1, that will be minus 5 by 14. And then also the bracket I will have minus 1 by 6 into 3 by 2, multiplying it I will be getting 3 by 12, minus 3 by 12. Okay, and now as these both are in multiplication, so they will get cancelled. This one comes out to be minus 1 and this one comes out to be 7. So now we are left with minus 1 by 7, and minus 3 by 2, 12 is also minus 1 by 4. If I simplify this one, so 3 ones are 3 and 3 fours are 12. So again this one comes out to be minus 1 by 4. And now if you move on further, LCM, that is 28. So I need to multiply both numerator and denominator of minus 1 by 7 by 4. That will be giving us minus 4 by 28. And if I multiply the numerator and denominator of minus 1 by 4 with 7, that will give us minus 7 by 28. And at last, if we add minus 4 minus 7, minus 4 plus minus 7, that would give us minus 11 by 28. So this was the solution, and the properties that have been used out as commutative. And again, there was another property that we have missed out on, that is distributive property, as I have told you in part 1, this distributive property. So hope you are clear with question number 1. Now let us proceed to question number 2. Now question number 2 says, write the additive inverse of each of the following. I have told you earlier the concepts of additive inverse. So the first that we have is 2 by 8. Okay, so additive inverse of 2 by 8, let me write it here. Additive inverse of 2 by 8 is the negative of the number itself. Is the additive inverse of 2 by 8 is minus 2 by 8. Similarly, moving on to the second part. Second part has minus 5 by 9, minus 5 by 9. So again, the additive inverse will be negative of a number, that will be minus into minus 5, that is plus 5 by 9. So again we will be writing additive inverse of minus 5 by 9 is 5 by 9. Hope you are understanding what I am telling to you. Moving on to the third, that is minus 6 upon minus 5. So the both negative signs will get cancelled out, and the result that we will be having will be 6 by 5. And additive inverse of minus 6 upon minus 5, or you can, I prefer this one because it is already mentioned in the question, is the negative of the number, that is minus 6 by 5. Okay, moving on to the fourth. The fourth one says 2 by minus 9. Okay, so friends, we all know that negative numbers are not in denominator, so we just transfer this one to the numerator, and this one comes out to be like this. So now additive inverse of 2 by minus 9, if we have minus 2 by 9, then additive inverse will be 2 by 9. So we will be writing is 2 by 9. Moving on to the fifth. Fifth we have 19 by minus 6. Same that we have done in question number 4. We have done in question number 2 part 4. This would come to the numerator. So additive inverse of 19 by minus 6 is 19 by 6. So now we are done with the question number 2. Let's move on to question number 3. Okay, so in question number 3 we have verify that minus of minus x is equal to x. So we need to verify that minus of minus x is equal to x. Okay, so in the first part we have x equal to 11 by 15. Okay, so if I put the value of x out here, so this would be minus of minus 11 by 15. And you all must be knowing that we can take this as minus 1. Okay, so if a negative number is multiplied to a negative number, the result would be positive. And if we have a result positive, okay, so we are done, that result would be positive. Now leave the signs. Let us see what is 1 into 11 by 15. That is 11 by 15. So here we come out with plus 11 by 15. And that is what? That is x given to us from the question. Moving on to the second, we have x equal to minus 13 by 17. X equal to minus 13 by 17. So again putting this value of x in this, so we have minus of minus, and again we have a minus 13 by 17. Okay, and now again if I take 1 out here, then this would come out to be 13 by 17. So I would just write it as minus of 13, this will be plus 13 by 17. And again if I take this one as 1, then multiplication of the negative with a positive is a negative, and if I multiply 1 into 13 by 17, that is 13 by 17. So I am left with minus 13 by 17, and that is what? That is the value of x that is given to us from the question. So now we are done with question number 3. Let us move on to question number 4. Question number 4 says find the multiplicative inverse of the following. Okay, again multiplication inverse I have taught you earlier. So for the first we have minus 13. Okay, so multiplication inverse is basically the reciprocal of the number. So for minus 13 I have multiplicative inverse of minus 13 is 1 by minus 13 or minus 1 by 13. Okay, now moving on to the second, we have minus 13 by 19. Okay, so we will be writing multiplicative inverse of minus 13 by 19 is reciprocate the number, that is 19 by minus 13, that is minus 19 by 13. You will be getting the answer in this form, but it is always preferred to write a negative number in numerator. So that lets us to the third part. Third part says 1 by 5. Okay, so I will be writing multiplicative inverse of 1 by 5 is 5. Fourth, we have minus 5 into 8 into minus 3 into 7. So first we need to simplify this one, and then we need to reciprocate or we do multiplicative inverse of the result. So we are having minus 5 by 8 and then multiplying it with minus 3 by 7. So as you can see out here that nothing is common, so nothing is getting cancelled, so we just multiply them directly. So minus 5 into minus 3, that is 15, and we have 8 into 7, that is 56. Okay, so that is 56. So I will be writing multiplicative inverse of 15 by 56 is 56 by 15. Hope you are cleared with this one. That leads us to fifth part. So in fifth part we see minus 1 into minus 2 by 5. Okay, so if I multiply a negative number to a negative, the answer will be positive. And 1 into 2 by 5 is 2 by 5. And if I inverse it, so the statements would be multiplicative inverse of 2 by 5 is 5 by 2. Sixth part says minus 1. Okay, so again we will be writing multiplicative inverse of minus 1 is 1 upon minus 1, and we already know the negative is not in denominator, that comes out to be minus 1 itself. So multiplicative inverse of minus 1 is minus 1. That leads us to fifth question. Okay, so in fifth question we have name the property under multiplication used in each of the following. So in the first we see that minus 4 by 5, let me write this one for you, minus 4 by 5 and then we have into 1 is equals to 1 into minus 4 by 5. That is 4 by 5 minus. So in this part we can see that we are multiplying 1 to minus 4 by 5, and due to the commutative property we can also write that as 1 into minus 4 by 5, and here we can see that we are having minus 4 by 5, am I right? Yeah. So we are having minus 4 by 5 as the answer. So the property that is used is multiplicative identity because we have 1. So multiplicative identity is used. As you can see, if you multiply any number with 1, the answer will be the number itself, that is minus 4 by 5 in this part. And okay, so this was part 1. Let us proceed to part 2. So for part 2 we have minus 13 by 17, okay, and multiplied by minus 2 by 7 is equal to minus 2 by 7 multiplied to minus 13 by 17. Yeah. So here we can see that if we write minus 13 by 17 or into if we write minus 13 by 17 into minus 2 by 7, or if we write minus 2 by 7 into 13 by 17 of minus, the answer will be same. As you can see in this case, that if we multiply minus 4 by 5 into 1, or if we multiply 1 into minus 4 by 5, the answer will be same. So the property that is used is commutative property. Commutative property is being used, okay. And moving on to the third. The third, it says minus 19 by 29 into 29 into minus 19, okay. Is equal to 1. So this is given to us, okay. So here we can just simplify this, and we can see that the answer that we'll be getting, this will become minus 1, this one will become 1, and this one will become 1 too. So that we have 1. And as we can see out here that multiplicative inverse of minus 19 by 29 is 29 by minus 19, okay. And if you multiply the multiplicative inverse of the number with the number itself, the answer will be 1. So which property is used? Multiplicative inverse. Multiplicative inverse is used, okay. And that brings us to question number 6. In question number 6 it says multiply 6 by 13 with the reciprocal of minus 7 by 16. Okay, so we need to multiply 6 by 13 with the reciprocal of minus 7 by 16, and reciprocal of minus 7 by 16 is, okay, so we can write it as 16 by minus 7. And you can write this above, and now we can have, as you can see, that nothing, there is no common factor against them, so we will be writing them directly. That comes out to be minus 96 by 91, or if you just kept the multiplication negative sign out here, you will be getting 96 by minus 91, and that is obvious, you need to take the negative sign in the numerator. So the answer would be this. Moving on to question number 7. Question number 7 says, tell what property allows you to compute 1 by 3 into 6. Okay, so this is given somehow like this, 1 by 3 into, and we have 6 into 4 by 3 in the brackets, okay, and then we have, so it says that which property allows you to write this as 1 by 3 into 6 into 4 by 3. So it's very obvious, you have already studied, that's the associative property. That's the associative property. Moving on to the 8th. So here we see question says that is 8 by 9 the multiplicative inverse of minus 1 by 8. So first let us make the mixed fraction as the improper one. So we have that, okay, minus 8 plus 1, that is minus 7 by 8, and if we are having, okay, so this one would come out to be okay, so we are given like this, 8 into minus 1 is minus 8 and plus 1 is minus 7, so that comes out to be minus 7 by 8. And if I multiply minus 7 by 8 with the number that is 8 by 9, I would get minus 7 by 9. So it is not the multiplicative inverse. Why? Because if it have been the multiplicative inverse, the answer or the result that you will be getting should be 1. Okay, and that was the reason. Moving on to the question number 9. In question number 9 we have, is 0.3 the multiplicative inverse of, okay, so we are given with this. First we need to solve this one. We have 3 into 3, 9 plus 1, we have 10 by 3. Okay, and if I multiply this with 0.3, that is 3 by 10, I do get the result as 1. So yes, the 0.3 is the multiplicative inverse of 1 by 3. And now let us move on to question number 10. And now we are here with question number 10, part 1. So for the first part it says, write the rational number that does not have a reciprocal. Well, I will be quite sure that you would have guessed it earlier than me. That is none other than 0, because if you reciprocate the number, that will comes out to be an infinite. And now that moves us to part 2, the rational numbers that are equal to their reciprocal. That's very easy. We just take 1, because we have, if we take 1 and if we reciprocate it, that comes out to be 1 by 1, that is again 1. But there is one more number, minus 1. Okay, so if I take minus 1 upon 1 and just reciprocate it, okay, and if I reciprocate it, I will be getting 1 upon minus 1, and as we all know that negative numbers are not in denominator, so we will be left with minus 1 by 1, that is minus 1. So we are having two numbers that are 1 comma minus 1. Moving on to the third one. For the third it says the rational number that is equal to its negative. Well, we see that 1 is not equal to minus 1, 2 is not equal to minus 2, but 0 is equal to 0, because 0 is neither positive nor negative. So the answer to this one is 0. Now moving on to the question number 11. For the first part we have 0 has dash reciprocal. As we are done in question number 10 part 1, it does not have any reciprocal, so we write no. Moving on to the second one, it says the number dash and dash are their own reciprocals. Again done in the second part of question number 10, 1 and minus 1. Third one, the reciprocal of minus 5 is, so if we do a reciprocal of minus 5, that comes out to be 1 upon minus 5, that is minus 1 by 5. Moving on to the fourth one, reciprocal of 1 by x, where x is not equal to 0. It is obvious, because if x becomes 0, then it will be infinite. And here becomes that 1 by x, so reciprocal of 1 by x would be x. And now moving on to the fifth part. So in the fifth we have the product of two rational numbers is always a. Okay, so if I take any of the rational numbers, if I take minus 1 by 5 into 8 by 9, so I will be left with minus 8 by 45. And we see that this is a rational number too. So if we take product of any two rational numbers, the answer will be rational always. So the product of any two rational number is rational. That gets us to the sixth part. The reciprocal of a positive rational number is. So let me have many of the positive rational numbers. I can take 5 by 8. The reciprocal comes out to be 8 by 5. And if I take any of the other, let me take 498 upon 922. Reciprocal comes out to be 922 by 498. and in both the cases the reciprocal is positive. So the reciprocal of a positive rational number is positive. So here we come to the end of exercise 1.1 and now we will be proceeding to exercise 1.2.